In this video, we're going to talk about another common financial shortcut, an annuity. An annuity is a fixed set of cash flows that goes for a period of time, say $5 every year, $2 every month, $1,000 every week, and then stops. Beyond that, the cash flows are zero. The value of a perpetuity is given by this equation here, which you can see is based on the perpetuity equation, cash flow divided by interest. To see why that's the case, think about purchasing a set of cash flows from the bank. If you would like to buy $5 every year forever, that's actually easy. That costs you 100 in this case. Okay. But that's not what we want. What we want is $5 for 20 years and then zero thereafter. So let's actually subtract from this another perpetuity that starts in year 21 and goes forever after that. The value in year 20 of this perpetuity is also the cash flow divided by interest. In this case, it's also $100. Now we're going to sell that, we're going to give it up, so it's going to have a positive value. But that's the value as of year 20. To get its value today, the present value, I need to take that and discount it back 20 more times. Well, I should do that on my calculator, I think. So let's see, I have $100 divided by, in parentheses, 1.05 to the power of 20 equals 3769. Alright, and if I add these together, what will I get? Well, I get 0 out here beyond 20, $5 between now and 20, and a present value, 100 minus 3769, $62.31. The formula comes from just subtracting these two things. Now what I'm going to do is collect terms on C minus R, or C over R, and so you can see that the annuity formula is driven by the value of a perpetuity that starts next period and ends after 2 periods. Now the nice thing about this is your calculator is designed specifically to solve this problem. On your calculator, there's a present value button that serves as the PV in this formula. You also have a button called payment, one for interest, and it's called I over Y, and one for the date, and on your calculator that's called N. You also have the ability to incorporate an additional payment at maturity on date 20. In this case, there is no additional payment on date 20. You'll use that in, say, bond formulas. So the future value will be 0. So the easy way to solve this is to go to your calculator and use the annuity buttons, which are in this shaded row right here. This is a 20 period, and it's 20, annuity, at 5% interest. Now your calculator uses percentage rate interest, not decimal. This is $5 payment, no additional payment at maturity. Compute the present value, $62.31. Again, your calculator changes signs like we did. This is saying you would be willing to invest, give up the use of, spend $62.31 to buy $5 each year for the next 20 years. There's lots of examples of this. Remember the work training example we did in the simple present value and future value, valuing $125 every month for the next 9 months with a per month interest rate of 0.5%. Well, the value of that set of cash flows can be computed one cash flow at a time, or more simply, the present value is a cash flow divided by interest times the adjustment factor, reflecting the fact that it starts next month and ends after 9 months. And you can do that pretty simply on your calculator. It's 125 payment. Again, 0, no additional value in the future. 9 months. 0.5% interest. Present value is $1,097.38. Same as we got last time, just faster. So let's do another quick example. Let's go back to our lottery example. What is the value of an annuity prize with $175 for the next 30 years? Well, the value is the cash flow over interest, starts next year, ends in 30 years. Again, the quick way to do this is on your calculator. 175 is the payment, still 0 future value. 30 years, 5% interest. Present value is $2,690,18. Now, if you were asked to choose, the best of the 3 options is the annuity prize. If you wanted the cash today, you would take the annuity prize and sell it for $26.90. If you wanted the cash forever, you would take the annuity prize, invest $2,000, generate $100 every year forever, and have $690 left over today. No matter what your preference is for the cash flows across time, this is the best price to take. Now, a nice thing about annuities is you can also generate the future value. The future value formula is very similar to the present value formula. Starts with the the perpetuity formula. The only difference here is this reflects the value that it will grow to after T years and the value at the date that you give it up. So where does this come from? Well, the present value of an annuity that goes for n T years is equal to the cash flow divided by interest. You start next period, you give it up T periods from now, and all I'm going to do is take this forward in time, multiplying the entire thing by interest, for T periods. Taking this through the bracket, you get the future value is equal to C over R interest T periods, and then it cancels in the second half, minus 1. So suppose that we go back to my profit sharing program from Ace Hardware. Suppose that I set aside $50 every month for a total of 73 months. Now, with future value, the important thing is the total number of payments. How much does that grow to on the day of my last savings payment? Well, the future value is the payment divided by interest carried forward 73 times. Now, you ask why that's not 72. It's because I made a payment at date 0. And for each of the next 72 months, 73 payments total. Again, your calculator can be used for this. I'm going to start with nothing today. Make 73 $50 deposits, $50, 73 of them, earning 1% interest over the life. And now I'm just going to compute the future value. Turns into $5,337.85. A fair amount of savings over the life for just $50 per month.